The Marauder is an all-out speed machine that feels like piloting a ground-hugging jet fighter. Because of the stable long wheelbase steering characteristics and rear suspension, the Marauder will be just as happy on the city streets as it is on the cycle track. The original Marauder was created in 2002 as an experiment to see if I could duplicate the aerodynamics and speed of some expensive commercially produced LowRacers, and it was a great success. The second version of the Marauder shown in this plan came 6 years later and includes several improvements, although the general size and position of the cycle is almost unchanged. Marauder M2 includes a rear suspension to make street racing a lot more comfortable, as well as the ability to adjust the bottom bracket to riders of any height. M2 also takes the seat a little lower and adds more back support. The entire build was made in a few weekends using only an AC welder, angle grinder, and the basic hand tools all garage hackers own. This plan will show you how you can build your own lean, mean racing machine. The entire rear section of the Marauder is made using an unmodified stock rear triangle from a typical suspension mountain bicycle. As shown here, you will need the complete rear triangle, the suspension spring, and at least the part of the main frame that contains the tube that connects the rear triangle to the frame, allowing it to pivot. The entire Marauder frame is made from 1.5-inch mild steel square tubing with a 1/16 inch wall thickness. This tubing can be ordered from most steel suppliers and is very easy to cut and weld. Steel suppliers like to rate tubing wall thickness using a gauge number, so 1/16 wall tubing will be called 16 gauge tubing. And although there is a slight difference between the two, your best bet is to tell them you want a length of 1.5-inch square tubing with a wall thickness as close to 0.0625 inch, which is 1/16 of an inch. If you are a heavy rider, over 250 pounds, then you should ask for the next size after that, which will likely be 14 gauge tubing or 0.078 inch wall tubing. Round tubing should be avoided for this project as it will yield a very flexible frame, which will likely be out of alignment after all the welding is completed. The rear frame tube runs from the pivot point of the rear swing arm to the joint between the seat base and back. The exact length of this tube is based on the geometry of your rear swing arm suspension system and is cut a little longer than needed at first so you can cut it down later. To start with, cut a 24-inch length of the square tubing to become your rear frame tube. 24 inches is more than you will probably need, but it's better to trim a little than end up too short. Once cut, you will need to make the fish mouth at one end of the tube in order to make a good joint between the swing arm pivot tube and the rear frame tube. In this photo, I have cut half the fish mouth after tracing around the actual suspension pivot tube as a guide. This photo shows the completed fish mouth cut made at one end of the 24-inch long rear frame tube so that the swing arm pivot tube fits perfectly. You will want to ensure that the pivot tube is aligned parallel with the frame tubing by placing a straight edge over one end of the pivot tube so you can compare it with the frame tubing. You will want to ensure that the pivot tube is aligned parallel with the frame tubing by placing a straight edge over the end of the pivot tube so you can compare it with the frame tubing. If the pivot tube is not parallel, your rear swing arm will not be parallel with the rest of the bike. Here you can see the swing arm pivot tube tack welded to the rear frame tube on all four corners. Once you have the part tack welded and it has been checked for alignment, you can continue welding the joint starting with the top and bottom and then the sides. To ensure that the tube is welded in line with the frame tubing, place a straight edge across one end of the pivot tube and check it against the length of the boom each time you make a weld. The order of operations is very important when you are welding parts together. Since some distortion due to heat is always present, you will need to choose which side of a joint are welded first in order to minimize the overall distortion. Here we need to keep the alignment between the rear triangle and the main frame, so the top and bottom of the swing arm pivot tube is welded first, as shown here. This way the part is held in place when you complete the side welds, the ones that are likely to mess up the alignment. The entire joint should be welded as shown here. Once the parts have cooled, you can tap the plastic bearings back into the pivot tube and then bolt the rear suspension triangle back into place. The pivot tube may have warped slightly due to heat distortion, so it may take a bit of effort to get the bearings to fit back into the tube. If the distortion is extreme, you may need to work the tube back into shape using a large hammer. The rear triangle is bolted onto the rear frame tube, completing a large chunk of the building process. As shown here, the installed rear triangle can pivot up and down freely, and it should be in line with the rest of the boom when viewed along the length of the main boom. Currently, there is nothing to connect the suspension spring to it, but that will change in the next few steps, so bolt it to the rear triangle if it isn't already. The seat tube is a 19-inch long piece of 1.5-inch square tubing that will serve the function of connecting the suspension spring as well as becoming the support for the rear of your seat. This tube is cut to a total length of 19 inches, and then one end is cut off at 51 degrees as shown in the next diagram. The resulting seat recline angle will be 141 degrees, which is 90 degrees plus 51. This is a comfortable seat angle, but if you have other plans and understand how this angle will affect the rest of the frame, then feel free to alter the seat angle to suit your needs. A few degrees either way will not really be noticeable. A more upright position will place your head up higher, but could become uncomfortable if increased too much, making it difficult to pedal or even reach the handlebars. On the other extreme, a laid-back seat will put your head quite far down, making it difficult to see properly in traffic or even over your own feet. This photo shows the seat tube after cutting the 51-degree angle from the end. When the seat tube is welded to the frame, the resulting seat angle will be 141 degrees. Cut one end of the seat tube as shown in this diagram and the last photo. The top part of the seat tube is cut off at 90 degrees and needs to be capped off to keep out moisture and anything else that may want to crawl inside. It is a rule of mine to never leave an open-ended tube, as this looks totally unprofessional, allows moisture into the frame, and can be a hazard due to the sharp edges of the tube. A simple cap can be made by cutting out a 1.5-inch square section of some scrap tubing as shown here. The cap is simply welded along the seams using only enough heat to fill the joint with weld metal. After welding the cap to the open end of the tube, use a flap disc or sanding disc to clean up the joint so that the tube will look like it never had an open end. Here you can see the capped seat tube after a few minutes of joint cleanup. These little details will make your finished bike look so much more polished. Since you are building your LowRacer using parts from various sources, which may differ from mine, the best way to ensure that your frame geometry turns out properly is to build it from the ground up, literally. The first requirement is the clearance from the underside of the rear frame tube to the ground, which should be 4.5 inches in height and parallel to the ground. To set this up, I simply found a few objects, my vise and drill box, that were 4.5 inches tall and placed them under the frame tubing as shown here. With the frame supported and the rear triangle populated with the wheel and suspension spring, it is easy to see where the suspension spring needs to connect to allow at least 2 inches of spring travel. Try to choose a seat tube position that allows the rear wheel to be lifted off the ground 2 inches, but keeps the seat tube as far back as possible to keep the wheelbase short. The next few steps will make this more clear. The seat tube is placed on the rear frame tube in a position that will allow the suspension to travel properly when the main boom is placed at the required height from the ground. There are 2 conditions that need to be satisfied here. To ensure that you get the correct placement of the seat tube, you will need to install the proper rear wheel with a fully inflated tire and have the suspension spring you plan to use installed on the rear triangle. A clamp will help you find the best place for the seat tube as shown in this photo. If you place the seat tube way ahead of the rear triangle and try to connect the suspension spring to the top of the seat tube, you will have added an extra 6 to 8 inches of unnecessary length to the frame, which will make it very long when completed. Yes, this would indeed work and might be a good way to earn some extra battery or luggage space, but unless that is your goal, the seat tube should be placed as far back as possible, putting the suspension spring mount lower on the seat tube. In this photo, I have the seat tube clamped to the frame tube as I try to find the optimal mounting position, which was about 15 inches from the center of the pivot tube to the rear edge of the seat tube. If I lifted the rear wheel off the ground 2 inches, the top of the triangle had about half an inch of clearance before it would strike the top of the seat tube, so this was just fine for my suspension spring, which only had 1.75 inches of total travel. When you find the optimal place, just mark that position on the frame tube so that you can weld the seat tube in place. Here you can see how the other end of the suspension spring will attach to the seat tube. The spring should be as close to the seat tube as possible without actually touching it. This photo shows the seat tube tack welded to the optimal place on the rear frame tube after checking the swing arm travel. A few small tack welds are first made to the corners of the joint so that you can ensure that the seat tube is in line with the frame tubing. View the parts from all angles and manipulate the seat tube if an alignment adjustment seems necessary. Before you complete any of the rear tube welding, another tube is to be tack welded in place that will not only support the suspension spring, but make the rear of the frame much more strong. This tube should have a diameter of 1 inch. I chose to use a 1-inch square tube with the same wall thickness as the rest of the frame as shown in this photo. As for length, look at the next few steps to see how this is determined. As shown here, this small tube simply forms a triangle between the seat tube and the rear frame tube and provides a support for the suspension spring. The actual angle is not critical, and the tube simply needs to provide a place for the suspension spring and mounting tabs as will be shown in the next few steps. Here you can see the optimal position for the suspension spring, which is about half an inch away from the seat tube and support tube. Once you have determined the best position for the suspension support tube and cut the proper angles at each end, tack weld it in place as shown here. Again, the exact angle and position of this tube is not critical. It simply forms a triangle between the seat tube and the frame tube and provides support for the suspension spring. Once the support tube is tack welded to the frame and the suspension travel is double checked, complete the welds as shown here, starting with the front and rear of the joint. The sides of the joint are completed last to keep side-to-side frame distortion to a minimum. This photo shows the triangle made by the completely welded suspension tube. Since the triangle is the strongest geometric shape, this adds great strength to the frame and keeps the force of the suspension from flexing the seat tube. Once the suspension support tube has been completely welded, you can go ahead and finish the seat tube welds as shown here. The inside of the joint near the rear of the frame has a very narrow angle, so you don't have to weld this joint if you don't think you can get at it. The triangle formed by the suspension support tube adds more than enough strength to the frame. With the last welds completed, your rear frame section is now finished. This photo shows what the rear of the Marauder frame will look like. The suspension spring needs to connect to the rear of the frame just like it did on the original cycle you used for parts. You can make suspension mounting tabs from some 1/8 inch thick flat bar, plate steel, or just hack them off the original donor frame like I did. This photo shows the cutting lines I made on the original frame in order to hack out a pair of suspension mounting tabs. By using the original frame, you end up with bolt holes already drilled for you. The suspension mounting tabs are about 1 inch wide and 1 3/4 inches in length. But this is another part that is made to fit your frame, so cut them whatever size you need in order to place the suspension spring in the correct place. Here you can see my suspension mounting tabs and the bolt that came with the shock. I recommend that you use the original bolt that came with the suspension spring, as it is specially made to tighten up without adding too much friction to the shock pivot. If you don't have the original bolt, use a quality fine thread bolt of the appropriate size with a plastic lock washer so that it can be installed in such a way as to allow the mounting tabs to move freely, yet remain tight. Here you can see how the suspension mounting tabs will hold the spring to the frame at the joint between the seat tube and the support tube. I like to install the bolt and then clamp the tabs in place for tack welding, as this ensures they are placed in the correct position. Once the suspension mounting tabs are tack welded to the frame, remove the shock and complete the welding as shown here. It is important to remove the shock, as the little plastic bearings will surely melt from the welding heat. Once again, we will be building from the ground up, which ensures that you get your frame geometry perfect and makes angle finding very simple. Prop up the rear of the frame using the same object you used before, and then find another object that is 11 inches tall. The center frame tube is a length of square tubing cut to a length of 24 inches. This tube will form your seat base mount and travel upwards to join the tube that allows the bottom bracket to adjust for different riders. The height of this tube at the front of the bike is 11 inches from the ground, as shown in this photo. Once the front of the center frame tube is set up so that it is 11 inches from the ground, draw a line where the rear of this tube crosses the joint at the end of the seat tube as shown here. This line will then be used as a guide for cutting so that the center frame tube can be welded to the rear of the frame. Doing things this way ensures that your angles are correct without ever having to know what they really are. My angles may differ from yours due to the donor parts used, so this method is best. With one line drawn, use a square to transfer the line around the tube for cutting with either a zip disc or a hacksaw. Once you have cut the extra tubing from the rear of the frame, prop up the parts back the way they were and then test to make sure the joint fits properly. Here you can see the two parts back in place after cutting. Once you have cut the joint and verified that the parts fit together properly, the two tubes can be tack welded on top and bottom as shown here. By using a bit of leftover square tubing and a pair of clamps, you can ensure that the two parts remain parallel when welding. After tack welding the joint, place the frame back up on the blocks and recheck the ground clearances between the ground and the frame. With the guide tubing still clamped to the frame, complete the top and bottom welds as shown here. Once completed, you can weld the side of the joint that does not have the clamps installed, and then remove both clamps. The remaining joint will be completed once you remove the clamps. This photo shows the last side joint to be completed. Here you can see the joint completely welded around all four sides. Thanks to the clamps and order of operations, your frame tubing should look perfectly aligned when viewed from the end. As explained earlier, the Marauder has an adjustable bottom bracket so that riders of various leg lengths can adjust the pedals to the correct position for optimal performance. To keep the pedal height parallel to the ground during adjustment, the tube shown here will be installed parallel to the ground in front of the center tube so that it can carry the adjustable bottom bracket. Cut this tube to a length of 17 inches with 90-degree cuts at each end. If you are taller than 6'5", then add 1/2 inch for every inch taller you are than that. This extra length will keep your feet clear of the front wheel during sharp turns. While keeping the frame propped up the same as it was in the last few steps, add the bottom bracket tube as shown here so that it is parallel to the ground and at a height of 11 inches as measured from its underside. As shown here, a line is drawn at the point where the bottom bracket tube meets the center tube on the corners. Use a square to transfer the line to both sides and then make the cut with whatever tool you prefer. The welding procedure for these tubes is the same as before. Place the clamps along the side with a square tube, then tack weld the top and bottom corners. After tack welding, place the frame back on the block to check clearances and then weld the top and bottom of the joint. The guide clamp remains in place for all welds except for the one it covers. Here you can see the top and bottom of the weld joint completed. Once you have the adjustable bottom bracket tube welded to the center frame tube, your frame is almost complete, and we will move on to working on the front end. The next frame tube will join the front of the adjustable bottom bracket tube to the head tube, completing the Marauder frame. Since we will continue installing tubes while the frame is set up on blocks, you will need to acquire your front rim, tire, head tube, and matching forks as shown here. If your head tube and front forks are not from the same bike, this is not important as long as all of the parts fit together perfectly as shown here. If a head tube is too long for the fork stem, don't worry, as we will do shortening surgery on both parts soon. The fork should spin freely in the head tube once all of the hardware is installed. Once you have cut your head tube from the donor frame, it will need to be ground clean as shown here. I usually rough grind with a heavy grinder disc and then finish up with a sanding disc. The completed work is usually as good as new. Unless your head tube is no longer than 4 inches, you probably want to shorten it as the extra length is completely unnecessary. I recommend you cut the head tube down to 3 inches and then cut the forks to match. This procedure is easy to do. Start by cutting the head tube to a length of 3 inches. Measure a few points around the tube and then place a strip of tape around the marks to ensure that you are cutting a straight line. When the head tube has been cut, take the leftover piece and place it in the center of the fork stem as shown here. Now you know exactly how much material needs to be removed from the fork stem, indicated by the lines I have drawn. Once the fork stem has been cut to remove the unnecessary section from the middle, place a gooseneck into the forks as shown here and then tack weld the parts together. The gooseneck will ensure that both stem segments line up perfectly. When you have 3 or more small tack welds on the stem joint, remove the gooseneck. Before you make the final welds, tape around the fork threads to protect them from welding spatter. You also need to have your bearing race installed before you weld. That isn't shown in this photo. Once you have welded around the fork stem as shown here, you may need to grind a little weld away in order to get the stem to fit into the head tube cups. Only take off as much weld metal as necessary, making sure there is a hill rather than a valley around the weld. Once the shortening operation is completed, you will have a complete 3-inch long head tube and its matching fork set, something that is almost impossible to find in the wild. It's the small details like this that make a project look professional when completed. The final tube that completes the Marauder frame is shown clamped into place here. This front frame tube is responsible for holding the head tube at the required 58-degree angle and connecting it to the bottom bracket tube. Start with a length of tubing about 14 inches and then clamp it into place as shown in this photo so that the head tube angle can be set. The goal is to cut the tube so that the head tube is set at 58 degrees as shown in the next diagram, and so that the front wheel has at least 2 inches of clearance between the frame. With a head tube angle of approximately 58 degrees, the Marauder will handle very well at medium and high speeds. Head tube angle is measured by an imaginary line extending through the center of the head tube towards the ground as shown here. A few degrees either way will not have much effect on the final handling characteristics. The front tube and bottom bracket tube need to be both cut to the appropriate angle in order to avoid having any open end in the frame. To get both angles, simply mark the point at which the 2 tubes meet at the top as shown here. Once you have these points, the cut lines are taken from there to the corners at the other side of the tubes. After cutting, the 2 tubes will fit together perfectly without any gaps. The head tube cut is found the same way by marking a line along the head tube on the top of the front tube as shown here. Your front wheel should be at least 2 inches away from the other frame tubing when doing this, because there will be about ½ an inch taken away by the fishmouth cut. In the end, you want your front tire no closer than 1.5 inches from any part of the frame. Before you cut, mark an arrow that points to the head tube, as the tube will look similar on both ends after cutting the angles. Once you cut the 2 angles at the ends of the bottom bracket tube and front tube, you will need to make a fishmouth cut at the end that will carry the head tube. Use the leftover head tube material or something similar in size to trace the fish mouth as shown here. This is done on both sides of the tube from corner to corner. Notice the arrow pointing towards the head tube to avoid confusion. Try to stay just outside the traced line as you cut the fish mouth for the head tubes as shown here. If your head tube angle is not perfect after installing the front tube, you can always grind out a little more metal if needed. As a general rule, cut a little less and adjust as you go. Once the head tube makes a good joint with the front tube, tack weld it in place in two corners, making sure it is in line with the square tubing. With the head tube tack welded in place, set up the main tube as it was before as shown here, so you can verify that the angle is close. If you have already cut the bottom bracket tube angle, then the two parts should fit nicely together with the head tube close to the required angle. The head tube should not only be near the required angle, but also in line with the other frame tubing so that the wheel forms a line with the tubing when placed in the straight ahead position. If your head tube isn't fully aligned right now, break the tack welds and make repairs. This photo shows the last frame joint to be welded. This joint is your final chance to correct any misalignment that may have occurred in the previous joints. A look down the length of the frame should give you some indication if this joint should be adjusted in one direction or the other. The goal is to have your front and rear wheels line up perfectly when they are pointing in the straight ahead direction. Here is my frame before doing a final spot check to make sure everything is good for welding. The head tube angle is very close to the goal of 58 degrees and the wheels are perfectly in line with each other. All ground clearances are good, so the head tube can be fully welded to the frame now. As usual, start with the top and bottom of the joint, being careful not to burn away the edge of the head tube. If you have an old set of head tube cups, bang them in and use them as a protector as you weld. With the cups installed, the tube will be less likely to become oval from heat distortion. The completed head tube joint is shown here after welding around the entire joint. You can now reinstall the head tube cups and put the forks and hardware back into the head tube. If you have not done so already, trim the bottom bracket frame tube so that the last two tubes can be set up for welding as shown here. Once again, a piece of square tubing is being used as a guide, along with several clamps. Before you make the two tack welds at the top of the joint, look down the length of the frame one more time to determine if any adjusting of the angles may be needed. If everything looks fine, make a tack weld on all four corners of the joint with the bike still propped up with proper ground clearances. The last main frame weld is done in the same order as before, top, bottom, and then the sides. At this point, you have completed all of the main steps and now have a rolling frame. Of course, you can't pedal or steer your creation yet, but the rest of the building process will seem to go fast from here. Here's my basic frame and wheels, now supporting themselves. The Marauder includes an adjustable bottom bracket so that riders of varying leg lengths can adjust the distance between the seat and pedals for optimal comfort and performance. Moving the bottom bracket is better than moving the seat because the steering system would also have to move with the seat, creating a very complex and difficult design to adjust the linkage system. Since the front derailleur requires a length of the seat tube to hold the clamp in place, leave a bit of this tubing when you cut away the bottom bracket from the scrap bicycle frame as shown here. The two plates shown here will form the sides of a clamp that will hold the bottom bracket against the side walls of the main boom so they can be adjusted to any place on the tubing. Cut two 3/16" thick pieces of plate to make the shapes as shown in this diagram. The round area is cut to conform to whatever size bottom bracket you decide to go with, and the two bolt holes will be drilled for 1/4 inch bolts. The two bolt holes are drilled at the edge of the plate so that there's about 1/8 inch of material between the hole and the edge of the plate. These two plates will form a vise that will clamp the bottom bracket to whatever position on the main boom you need to place it. When grinding out the traced circular area for the bottom bracket, place both plates in the vise so they can be done at the same time. This will ensure that the plates are exactly the same size. Try to make the gap as small as possible around the bottom bracket shell so that there is less distortion as the plates are welded. If the bottom bracket becomes overly distorted, it will be a serious challenge trying to screw in the hardware. In order to get the two plates aligned with each other at the correct spacing, a bit of frame tubing can be clamped between the two plates as shown here. This will allow you to set the bottom bracket into the correct position for tack welding, as well as ensuring that both plates are aligned with each other so the bolt passes easily through both holes. I also placed a sheet of paper folded in half between each plate and the sidewall of the tubing to allow a little clearance between the clamps. As shown here, I used an adjustable square to set the required 56 degrees in order to set up the bottom bracket and derailleur tube to place 2 small tack welds at the top of the joint. It may be a bit tricky to get this first tack weld in place while holding the bottom bracket in position, but once this is done, the rest is easy. The first tack welds are done at the top edge of the clamp plates to secure the parts together. Make sure that the derailleur tube angle is close to the 56 degrees and that the bottom bracket is at 90 degrees to the square tubing. The 2 plates will form a vise-like grip on the frame tubing when the bolts are tightened. To drill the holes into place, draw a line that represents the bottom corner of the frame tubing as shown here. Now you can punch and drill the holes using the line as a guide that will allow you to make sure the holes stay below the line. If the holes are not below the line, you will not be able to pass the bolts through because they will hit the frame instead. With the derailleur tubing cut to length, it's a good idea to cap off the open end of the tubing so that it looks better and keeps out any moisture. As shown here, a washer is welded over the end of the tube and then completely filled in around the joint and the hole. To fill in the washer hole, several passes are made around the edge until completely covered in weld metal. After welding the washer in place and grinding the area clean with a flap disc, the top of the tubing is completely sealed. The adjustable bottom bracket and included derailleur tube will be installed on the horizontal tube somewhere in the center as shown here. When you adjust the bottom bracket, the pedals will be the same height no matter where they are on the tube. This is the reason why the section of frame tubing that carries the bottom bracket is parallel to the ground. Because of the reclined riding position, you will need some type of back support. As shown here, the Marauder seat is made up of 3 parts, and the back support will need a small piece of 3/4 inch tube to hold it in place. To find the back support position that suits you best, have a helper hold the topmost seat board in place as you sit on the temporary seat. A clamp or angle finder can be used to remember the angle you thought felt best so that you can cut the support tube to fit. The backrest support tube is just a bit of 3/4 inch wide square or round tubing, and it's not that critical. As long as you get the correct angle, your seat will feel comfortable. After you cut and test fit the back support tube, cap off the open end using some scrap tubing or flat bar. You can then place the tube on the frame and tack weld it to place. With the back support tube installed, drop your test seat back onto the frame for one final test before completing the welds. Seat position is a very personal thing, so your preferred angle may look a lot different than mine. I chose a position that allowed me to see over the front of the frame, yet kept my head down as far as possible for better aerodynamics. The Marauder has indirect steering, which connects the handlebars to the front forks using rod and ball joints. For this design, we will require a second head tube placed in the center of the frame just ahead of the rider at the same approximate angle as the front head tube. This will be called the pilot's head tube, since it is the one that connects the handlebars. As shown here, you can use any head tube and forks, as long as the hardware fits together. Start by cutting the fork legs away from the stem as shown in this photo, and then grind off any excess material from both the fork crown and the head tube. Before cutting the fork legs, remove the bearing race from the fork stem by tapping it off using a chisel or hammer. This will ensure that it is not damaged by the grinder wheel when cutting the legs. It should be reinstalled once the fork stem is cut and ground clean. The head tube is shown here after grinding the excess tubing away. One of the holes has also been filled by welding around the hole. You can leave the other one open as it will be underneath the frame tubing. Draw a line around the base of the stem as shown here, leaving about an inch of material just below the top ridge where the bearing race was located. This will remove some of the heavy tubing that was once needed when the fork legs were connected and supporting the weight of a rider. In this steering setup, there will be very little stress on any of the steering parts. The large segment of fork crown material is not really necessary in our steering mechanism, since it will no longer be used to support the front end of a bicycle, only a small control arm. It can be removed by cutting along the line you drew earlier, After you have cut the thick stub from the fork crown, a weld must be made all the way around the underside as shown here. After trimming and securing the fork crown, reinstall all of the head tube hardware as shown in this photo so you can get ready to install the unit onto the frame. Notice the open hole is positioned at the bottom of the head tube so that the connecting tube will cover it up. The connecting tube is a piece of 1-inch square or round tube that will join the pilot's head tube to the frame just ahead of the seat base. This tube is not critical as the goal is to simply place the pilot's head tube at an angle close to the main head tube at some place on the frame that feels comfortable to you. As shown here, a length of tube approximately 6 inches is cut and then tack welded to the pilot's head tube at an approximate 45-degree angle. The only way you will find the optimal spot for the pilot's head tube is by trial and error, so drop in that test seat board so you can sit on the frame and see how much room you need. It may be a good idea to move ahead a few steps and build the handlebars before you decide on a head tube position. It will make finding the optimal spot easier. For me, the optimal distance from the head tube support to the seat corner was about 11 inches. When you do find the best position for the pilot's head tube, it will be tack welded to the frame as shown here. Also note that the fork stem and bearing hardware must be installed before you weld the head tube to the frame, as it won't be able to be installed later. The Marauder requires a very unique long and straight gooseneck in order to mount the handlebars to the steering head tube. You will not find anything like it on a regular bicycle, so we will make our own using a steel seat post or some mountain bike handlebars to extend a commonly available steel bicycle gooseneck. Your goal is to place the gooseneck clamp in a position that will allow your handlebars to clear your legs and knees when pedaling, yet keep your arms and hands in a very relaxed and comfortable position. Cut the clamp from the gooseneck so there will be enough material to make a good joint between the extending tube and the base of the gooseneck. As shown here, I cut the gooseneck an inch from the stem and ground the area to allow an easy weld of the two parts. The position and angle of the extending tube should place the top of the tube where the handlebars will mount, directly over the center of the gooseneck tube. This placement of the handlebars will remove any tiller effect from the steering so that the handlebar turns directly on its center axis. As shown in this photo, the handlebar clamp is positioned in such a way that if you drew a line extending from the center of the gooseneck tube, it would hit the center of the clamp. This is why the extender tube is welded in place at the slight angle. Often a home-built bike is never finished. There is always something you want to alter or think you can improve. Here shows a modification I made to my long gooseneck after deciding that I wanted the handlebars 4 inches closer to my body. To do this, I just cut a small wedge out of the gooseneck, bent the tube to fill the gap, and then welded it back solid. I have found that these old-style granny bars are usually perfect for overseat steering systems as they curve around your legs to give your knee clearance and put your hands in a very relaxed and natural position. For a more extreme LowRacer style handlebar, a cut-down straight bar can be used as it'll keep your hands very close to your body in order to keep your aerodynamics high. If you haven't already done so, complete the head tube welding by starting with the top and bottom of the joint as shown here. Here is the pilot's head tube assembly, ready to be installed on the frame at whatever position you have found most comfortable. Remember that all of the bearing hardware must be installed prior to welding the support tube to the frame, or you will not be able to install it after. The pilot's head tube and support arm are welded to the chosen position on the frame as shown here. The pilot's head tube and front head tube should be within 5 degrees or so of each other in order to make the linkage work properly. The Marauder steering system will connect the front forks to the handlebars using a pair of control arms and 2 ball joints so that the exact movements of the handlebars will be transferred to the front forks. This will feel as if you are holding onto the handlebars directly connected to the front forks, just like a regular bicycle. The 2 control arms shown here are just pieces of 1/8 inch thick flat bar cut to the size shown in the next diagram. Cut out the control arms from the flat bar or plate as shown here. The hole at the end of the control arm should match the bolt hole in the rod ends you choose, which will probably be between 1/4 inch and 3/8 of an inch in diameter. When you are trying to make 2 identical parts with your grinder, A nice trick is to place them both in a vise as shown here. This ensures that both parts end up the exact same size when completed. Here are the two control arms after cutting, as well as the two ball joints, also known as spherical bearings. Tack weld the pilot's control arm to the base of the fork stem on the left side as shown here. The control arm should be installed at about 90 degrees to the fork stem and slightly tilted as if forming a line up to the front fork crown. The control arms are always installed on the left of the frame, so the control rod will not get in the way of the front chain rings. Also place your ground clamp on the fork crown to keep the current from flowing through the bearings. If you clamp to the frame and then weld the fork crown, you will likely damage your bearings from the welding current. Tack weld the front fork control arm to the fork crown as shown here. Again, just use a large tack weld in the center and imagine a line drawn between both control arms when you are choosing this angle. The angle is shown clearly in the next photo. This photo shows the control arm welded to the forks at an angle that places both at the same angle. I don't recommend you complete any of the welds on the steering parts until they have been fully tested. This photo shows how one of the bolts is welded to the end of the control rod in order to allow the ball joint to screw in. The second bolt locks the ball joint once it has been set to the correct position. The control rod is cut to a length that will allow some bolt adjustment for final tuning of your steering linkage. Although you can adjust the ball joints in the control rod by moving the bolts, you should try to get them cut to the optimal length. Place your front wheel in the straight ahead position and then turn the pilot's head tube to the straight ahead position and measure the hole-to-hole distance between both control arm holes. This is the distance your ball joints need to be apart from each other. As shown here, the steering is aligned and there is still plenty of room for adjustment either way by moving the ball joint bolts in the control rod. This photo shows why the control arms and rod need to be on the left side of the Marauder. If the rod was on the other side, it would be in the way of the chainring and not function at all. Also notice there's plenty of room between the crank arm and the control rod. Once you have your control rod and ball joints installed on the control arms, make sure the steering moves to the left and right without sticking. If the control arms are not at the optimal angle, the ball joint body may rub against the control arm during sharp turns, adding friction and wear to your steering system. Since the control arms are only tack welded at this point, it's easy to force them into the optimal position with pliers. Here is the Marauder getting very close to that initial test ride. On a very low recumbent bike or trike, the chain must pass under the pilot's seat in order to reach the rear free hub. This is rarely a simple path from one point to the other. Some recumbent bikes have 2, 3, or even 4 chain guide pulleys in order to route the chain around all of the obstacles from the front to the rear. The nylon idler pulley shown here is common on fitness equipment that uses a wire or rope. They are a perfect size to carry a bike chain, have built-in ball bearings, and will probably never wear out in this use. I recommend you use a pulley of at least 3 to 4 inches in diameter, and it must have a ball bearing in order to work properly as a drive-side chain guide. Skate blade wheels have been commonly used for home-built idlers by carving out a slot in the chain using a grinder or lathe, but this should really be avoided as there will be a power loss due to friction from the small diameter of the pulley and the softness of the material. You will need to install a length of chain across the top of the front and rear chain rings when you're setting up the idler pulley as shown here. Notice how the chain is routed under the seat when the pulley is held in place just behind the seat back. When you have found the best place for your idler pulley, you can mount it to the frame by either welding a nut to the side of the frame as shown here, or by welding a bolt to the frame. If your pulley rubs on the frame, just add a few washers to keep it away from the frame tubing walls. If you are worried about ground clearance issues, you can use the double idler pulley system shown in this mock-up instead. By using 2 smaller 3-inch idlers, the chain does not fall below the lowest part of the frame. The return chain is never under tension and is fairly loose, creating a sagging arc from the front of the bike to the rear due to its own weight. You can build a very simple and effective return chain idler system by cutting up an old rear derailleur as shown here. This shows one of the many possible mounting methods for a return chain guide. This system keeps the chain from flopping around and also stops it from rubbing on the large drive idler no matter what gear you are in. The two chains can now cross, but are never in contact with each other. Much like handlebars, seating is a very personal thing with many options. Seat construction is totally up to you, and there are hundreds of different materials you could use to make a great seat depending on your personal preference. I made a simple 3-part seat from plywood based on the dimensions shown here. As shown in this photo, these 3 seat parts are held together by a pair of shelf brackets that I hammered into the correct angle. The foam will be glued directly to the wood using spray adhesive and then trimmed by following the edge of the seat board using a sanding disc in the angle grinder. Foam comes in all sorts of styles and hardness, so you might want to visit your local upholstery or fabric shop to find something you like. Avoid the temptation to cut up an old chair and steal the foam. It will probably be way too soft and will certainly need a covering. By carefully following the edge of the wood using a flap disc, the foam gets perfectly trimmed around the seat. Once completed, I slightly rounded off the edges as well. The hard foam seat is surprisingly comfortable even for the long rides. If you are good at fiberglass, you may want to try building a bucket seat from composite materials, like the ones made for professional recumbent cycles. The seat needs to be supported in 3 places: the base, the back, and the backrest. A few bits of 1/8" flat bar as shown here will do the job perfectly. If you are a rider who weighs over 200 pounds, then you should consider adding the frame support gussets as shown in this photo. These 4-inch long strips of 1/8" flat bar are really easy to install and will create a lot of extra strength in the most stressed part of the frame. It's now time to rip up your creation, clean up any messy welds, and then prep the metal for primer. Here's my completed Marauder frame, waiting for primer after a light sanding. After the primer is sprayed on, I hang my parts up to dry in the garage using hooks made of old road bike spokes. Primer needs to dry for at least a day before adding paint, which can really try my patience. To paint the frame, I just drop it on a few buckets in the backyard and then apply paint according to the instructions on the can. The results do look just as good as a professional powder-coated job, but are more likely to scratch if banged around. The two-tone effect shown here looks great and is easy to apply. Simply hold the forks by the stem after your main color is dry, and then wave the can back and forth around the fork tips, slowly moving away as you get about halfway up. The end result looks airbrushed. All of your bearings will now need to have fresh grease installed. To get at the lower bearing in the pilot's head tube, take off the top hardware and then drop it as shown here. Cabling a new bike is a bit of a chore, but if done properly, you only have to do it once. The brakes need to be fine-tuned so that they don't rub when not in use, but at the same time, grip the rim with optimal power when the lever is fully engaged. Each brake lever has an adjustment screw, and it should be screwed all the way in when you initially set up the brakes. If the brakes don't grab hard enough, slowly turn the lever adjustment screw counterclockwise to stiffen up the brakes. Setting up the front brake is done in the same way as it was done for the rear brake. There is an adjustment screw on the actual brake body, just like the one on the brake lever, so both should be screwed fully clockwise when first setting up the brakes. There are many styles of shifters for bikes, so you may have to do some shopping or scrounging to find the ones you like. My personal favorite has always been these old-style road bike levers as shown here. After an hour of routing cables and setting up brakes, the Marauder is ready to hit the streets and leave those upright bikes in the dust. If you have never tried an extremely low, long wheelbase recumbent before, then you might want to find yourself an empty parking lot and get some practice before getting out of second gear. I can easily ride my Marauder with a coffee in one hand now, but it did take some time to get used to it. On your first test ride, you will probably overcompensate with the steering. This is a tendency to flop the handlebars back and forth as you get started. This reaction will disappear as you start to trust the bike and yourself and get used to the steering characteristics. Thanks for watching this DIY video. With a little patience, a pile of scrap bike parts, and some trial and error, you can create just about any human-powered vehicle imaginable. If you need any assistance or want an opinion on an idea, stop by the support forum on chopzone.com and introduce yourself to the many creative fellow garage hackers. I'd like to hang around and chat a bit more, but there's a whole bunch of street out there that needs to be torn up with my LowRacer. When you get your project started, stop by the forum and show off your work sometime.